Dear learner, welcome to this technical session on geyser, basics and working. A geyser, also known as an electric water heater, is a household appliance that is used to heat and store water. It works by converting electrical energy into heat energy, which is then used to raise the temperature of the water stored in the tank. Electric geysers are a popular choice for households that do not have access to gas or solar-powered water heating systems. They are easy to install and maintain, and they provide a constant supply of hot water on demand. Electric geysers come in various sizes ranging from small 5-liter units suitable for single-person households to large 100-liter units suitable for families. The size of the geyser you choose will depend on your household's hot water usage. Most electric geysers have a tank that is insulated to reduce heat loss and maintain the temperature of the water. The tank is usually made of steel or copper, which is durable and corrosion resistant. The heating element, which is responsible for heating the water, is usually made of a resistive material such as nickel chromium alloy or copper. Electric geysers are available in two types: storage and instant. Storage geysers, as the name suggests, store hot water in a tank for later use. Instant geysers, on the other hand, heat water on demand and do not have a storage tank. Instant geysers are typically smaller in size and are ideal for households with limited space. One of the advantages of electric geysers is that they are easy to use. Most models have a simple control panel that allows you to adjust the temperature of the water and switch the geyser on and off. Some models even have a timer function which allows you to schedule the geyser to switch on and off at specific times of the day. However, electric geysers can be expensive to run, especially if you use them frequently. They consume a lot of electricity and can add to your monthly electricity bill. Additionally, they are not ideal for areas with frequent power cuts or unreliable electricity supply, as they rely on a steady supply of electricity to function. Electric geysers work by heating water in the tank using an electric heating element. When the hot water tap is turned on, cold water enters the tank and is heated by the heating element. The thermostat controls the temperature of the water, and when the desired temperature is reached, the heating element switches off. Electric geysers are generally less energy efficient than gas geysers, but they can be improved with the use of energy-saving features such as insulation and timers. Renewable energy sources such as solar power can also be used to power electric geysers and improve their energy efficiency. In short, electric geysers are a popular and convenient way to heat water for household use. They are easy to install and use, and they provide a constant supply of hot water on demand. However, they can be expensive to run and may not be suitable for areas with unreliable electricity supply. Okay, dear learner, Let us now discuss some maintenance related facts about the geyser. Electric geysers require regular maintenance to ensure their proper functioning and efficiency. Common maintenance issues include sediment buildup, thermostat malfunction, and heating element failure. Regular cleaning and descaling of the tank and heating element can help prevent sediment buildup. It is also important to check the thermostat and safety valves regularly to ensure they are functioning correctly. Regular maintenance of a geyser is also essential to ensure its longevity and efficient operation. Here are some of the tips on geyser maintenance. Number 1, check the pressure relief valve. The pressure relief valve is an essential safety feature of a geyser. It releases excess pressure and prevents the tank from bursting. Check the valve regularly to ensure it is working correctly. If it's leaking or not functioning correctly, have it replaced immediately. Number 2, inspect the anode rod. The anode rod is a sacrificial rod that helps prevent corrosion inside the tank. Over time, the rod will become depleted and need replacing. Check the anode rod annually and have it replaced if necessary. Number 3, drain the tank. Sediment and minerals can accumulate at the bottom of the tank and cause corrosion. Drain the tank annually to remove any sediment buildup. This will also improve the efficiency of the geyser. Number 4, check the heating element. The heating element is responsible for heating the water. If the element is faulty, it will affect the performance of the geyser. Check the element annually and have it replaced if necessary. Number 5, insulate the tank. Insulating the tank will help to reduce heat loss and save energy. It will also extend the life of the geyser by reducing the workload on the heating element. Number 6, check the thermostat. The thermostat controls the temperature of the water in the tank. If it's faulty, it can cause the water to overheat or not heat enough. Check the thermostat annually and have it replaced if necessary. Number 7, clean the tank exterior. Dust and debris can accumulate on the exterior of the tank, affecting its appearance and reducing its efficiency. Clean the tank regularly to remove any dirt or debris. Number 8, regularly check the connections and wiring. Faulty connections or wiring can cause electrical shorts or fires. Inspect the connections and wiring periodically to ensure that they are secure and not damaged. By following these tips, you can ensure that your geyser remains in good condition and operates efficiently. Regular maintenance will also help to extend the life of the geyser and save you money in the long run. Alright, dear learner, let us quickly do a self-test now by answering the following questions. Okay, dear learner, after answering these questions, we can now move to the next topic regarding the safety guidelines while operating or maintaining a geyser. Safety guidelines for working with a geyser. Working with an electric geyser can be dangerous if proper safety precautions are not taken. Here are some safety guidelines to follow when working with an electric geyser. Number 1. Turn off the power supply. Before working on an electric geyser, switch off the power supply at the main electrical panel to prevent any electrical shock or accidents. Number 2. Wait for the geyser to cool down. An electric geyser can reach high temperatures, so wait for it to cool down before attempting any maintenance work. Number 3. Use proper tools. Use insulated tools to avoid any electrical shock. Do not use metallic tools and do not touch any electrical part with bare hands. Number 4. Wear protective gear. Wear protective gear such as rubber gloves, goggles, and shoes with rubber soles to protect against electrical shocks. Number 5. Avoid water contact. Avoid contact with water when working on an electric geyser, as it can conduct electricity and increase the risk of electrical shock. Number 6. Hire a qualified technician. If you are not experienced in working with electrical appliances, hire a qualified technician to perform any maintenance work on the geyser. Number 7. Keep children away. Keep children away from the geyser, especially when working on it, as they may accidentally touch it or interfere with the maintenance work. Following these safety guidelines will help ensure that you can work on the electric geyser safely and avoid any accidents or electrical shocks. Dear learner, let us now briefly discuss about the heating coils used in electric geysers. The heating coil is a crucial component of electric geysers that heats the water in the tank. This part provides a comprehensive review of heating coils in electric geysers, including their design, materials, and efficiency. We will also discuss the factors that affect the efficiency of heating coils in electric geysers and how to improve their performance. We will try to examine the environmental impact of heating coils in electric geysers and the potential for new technologies to reduce their carbon footprint. Types of heating coils. There are two main types of heating coils used in electric geysers: immersion heating coils and surface heating coils. Immersion heating coils are fully immersed in the water and are more common in smaller geysers. Surface heating coils are mounted on the outside of the tank and are used in larger geysers. Components of heating coils. Heating coils consist of a resistance wire, insulation, and a protective sheet. The resistance wire is made of a high resistance material such as nickel chromium alloy that heats up when an electric current is passed through it. The insulation prevents the current from shorting out, and the protective sheet prevents corrosion and damage to the wire. Operation of heating coils. When an electric current is passed through the resistance wire, it heats up and transfers heat to the water in the tank. The thermostat regulates the temperature of the water by turning the heating element on or off as needed. Efficiency of heating coils. The efficiency of heating coils in electric geysers is affected by several factors, including the size of the coil, the temperature of the water, and the insulation. Improving the insulation and reducing the heat loss from the tank can improve the efficiency of heating coils in electric geysers. Environmental impact of heating coils. Heating coils in electric geysers contribute to greenhouse gas emissions through the generation of electricity. New technologies such as solar water heaters and heat pump water heaters can reduce the carbon footprint of electric geysers by using renewable energy sources. So, dear learner, after discussing the safety guidelines for handling a geyser as well as about the heating coil used in it, we can do a self-test at this point by answering the following questions. After answering these questions, we can now proceed to the next topic about the power supply to the geyser and its maintenance. Geyser power supply. Electric geysers are widely used for water heating, but the type of power supply used can have a significant impact on energy efficiency. This part of the session provides a comprehensive review of the different types of geyser power supply, including single phase, three phase, and solar power, and discusses their impact on energy efficiency. We will also discuss the factors that affect the performance and energy efficiency of each type of power supply and how to select the most appropriate power supply for a given application. Electric geyser